I hate when someone tells me my code is shit, mainly because they are usually right. If you want to learn to code, don't do it at school. Schools are insanely bad at teaching you to code. I'm gonna elaborate on this a little. Basically, you first need to know how to walk before you can run, right? Simple as that. This game starts with the basics. You are supposed to pick up these cubes and just drop them down here between these two plants. So what you do is you step down, pick up the cubes, step down again, then again, and drop the cubes. Just like that. 5 very simple commands. Now, when I was at school, basically the very first lesson, they said, alright, so this is a for loop and you can repeat commands forever, stuff like that. In this game, you get to this very advanced mechanic at level 55. All that grind before, we still haven't unlocked basically one of the simplest commands used in coding. Also, I remember the first day I was learning about that, they were explaining how to use arrays in Python. And he wrote ARR equals new array or something. I don't remember what the syntax is. Basically, I remembered this is the exact line I need to write whenever I want an array. He didn't freaking even explain that the ARR he wrote at the start was a variable name. And I could name it whatever the shit I want. I could name it I hate this place, coding is dumb, equals new array. And it would have worked. But nobody said that. I think what I've learned at school mainly is that people who are too clever shouldn't teach. Not that they shouldn't really teach, but they don't have any understanding of what it's like to not understand something. And that made them bad teachers. Then there was a guy who was just like 1 year ahead of us, and he was one of the best teachers I've ever had. So he knew how we felt, how, empty our minds were. Too much talking, let's just code. I haven't read a single thing this lady is saying. I'm gonna have to do it again, because I'm interested. She says some fun stuff from time to time. Alright, it's too crowded. A good neighbor is a distant neighbor. Well, I agree. So we need to rearrange the data cubes as long as no data cube has more than 3 neighbors. Okay, now I see some SAT/CSP issue. Is it CSP? Constraint satisfaction problem. Yeah, that's it. But it's probably gonna be much easier than that. How the shit do we do it? I would say, go to any cube you want, and if it has more than 3 neighbors, you're gonna move it. Where should you move it? I have no idea. I feel this is gonna be random. So, nearest data cube in memory 1. Step to memory 1. Now what about these 2 people? Number 3 is their closest one. So I'm gonna say pick up what you're standing on and we'll see what happens, alright? So this guy stepped there. He waited for the other person to pick it up. Then he basically ended his program and this guy was still waiting. Alright, so we're gonna have to say something else. You've stepped to memory 1, but it's possible that you are not yet there. So can we say, if under you there isn't a data cube, meaning someone stepped there before you just repeat that? Would that work? Step to memory 1 and repeat. So basically, at this point, they all would have picked up a data cube. Then, I don't want them actually to pick up any data cube. I want you to only pick up a data cube if... Oh wait, I can't use the nearest data cube. Oh shit. I can't, can I? We have to do like a grid search. How the shit are we supposed to do a grid search? I have no idea how to approach this puzzle. Alright, screw it. No nearest, no stepping, no shit like that. Just step in a random direction. If under you there isn't a data cube, you're gonna repeat that. Here, there is a data cube under you. So you keep standing there, and for each direction, you're basically gonna count, just as in the previous puzzle, in last video's puzzle, you're gonna count how many data cubes there are around that puzzle, that data cube. Now, this doesn't take into account that there might be a person standing next to you trying to place down a cube. we'll figure that out later. But basically, let's say memory 2, and then you're gonna calculate in memory 1 what's memory 1 plus 1, right? Basically count the amount of data cubes around you that's in memory 1. Then, if memory 1 is larger than 3, you're gonna pick up the data cube and bring it somewhere else. Here, I might do a time optimization and say if memory 1 is already larger than 3, we're gonna break this loop. So let's say pick up the data cube there and, jump elsewhere. Before this jump, it means you finish this and it's not larger than 3. So then you need to jump back here and keep walking, basically. Leave that cube alone. But if that is larger than 3, you've picked up the cube, or you can, pick it up here, it doesn't really matter. I mean here. And what you need to do now is also keep walking, but this time you're gonna try and find a new place for the data cube. So I think I can reuse this bit of the code. Basically all the code. Right, we basically need to do the same thing, and in the else branch we're gonna drop the cube. Can I do it like this? No, I can't. If it's larger than 3, here. Alright, so if your item is a data cube, you drop it. Here, you've picked up the cube, and the jump is gonna be back here. This might work, it's a little confusing, but let's just walk through it again. Step in random direction, keep doing that until you are standing on a cube. Alright, this doesn't work already. So if you are not standing on a data cube, you want to repeat, but only if your item is not a data cube. So you're wanting to pick a data cube, so keep walking until you're standing on one. Once you're standing on a data cube, you count how many neighbors data cube has. If it is more than 3, you pick it up and jump back here and start walking again, this time with the data cube. So you skip this step. I think I've already discovered 2 issues just by explaining this. When should you step? You should step if you don't have a data cube in your hand, so you want to pick it up and there isn't a data cube you can pick up. Or, and I hope this is gonna work, or you have a data cube in your hand and there already is a data cube on the ground. So you want to put it down, but you can't. So keep walking. And I'm not sure this if statement is gonna work, because basically I want to put brackets around these first 2 things and then the last 2 things. But I think maybe in general, maybe not, but in this game, this end and this end is gonna group those 2, statements as if there were brackets around them. So then you count what's around you. If it's larger than 3, you want to pick it up, but only if you are holding a data cube. I mean not holding. So if your item isn't a data cube, then you want to pick it up. But if your item is larger than 3, I mean the memory, so there are 3 around, and your item is a data cube, you also want to jump away, right? No, you don't. You want to drop it. So drop the cube here, and no, if it's larger than 3 and you have the item, okay, yeah, you want to jump away. So can we put it together? Right, so if it's larger than 3 and you're not holding a data cube, pick it up. But if it's larger than 3 and you are holding a data cube, you just jump away. So let's do it a little differently. If there are 3 data cubes around your spot, you're always gonna jump away. But if your item isn't a data cube, you're also gonna pick it up. Now we can remove these 2 statements. So this works. And if you've reached the end of this for each, only if you're already holding a data cube, you drop it. Alright, I think this is gonna work. Let's try. Oh shoot, why are they calculating already? Alright, so that's wrong. They should have jumped. So this if statement probably doesn't work, or I messed it up. If there isn't a data cube and it's that, or Okay, never mind. Let's just write it normally so we can understand it. If you're not standing... No, let's start by your item. That's the clever thing. If you're not holding a data cube, so you want to pick it up. And if you're not standing on a data cube, so you want to pick up a data cube, but there isn't one. So jump. Keep walking until you find a data cube. If your item is a data cube, and currently you are standing on one, you can't drop it, even if you wanted to. So again, keep walking. This if statement, sadly, we have to get rid of. I might be able to edit it, but I would just need brackets, and basically I can't at this moment. Alright, so they should find a data cube. Each of these people should find the data cube and only then start calculating. Let's try again. Yeah, working. This person is calculating. So let's see. Why does she have 5 in memory 2? Alright, that's because that's the number right there on that cube. We don't care what the numbers on the cubes are. So she picked it up because the data cube has 5 neighbors. She only counted 4, but already triggered this if statement. She wasn't holding a data cube, so she picked it up, and now she's walking again. Your item isn't a data cube. That's not true. Your item is a data cube, and you are not standing on a data cube, so she should ignore this if statement. Yeah. So now calculate the number of neighbors again. Oh shit, I forgot to reset the memory 1 counter, calculating the number of neighbors. Let's do it here. So memory 1 is gonna be 0. That's a shame, because she would normally put down the cube there. And this time it has to work. I'm just gonna let it run. Okay, it's not working. This lady, why aren't you putting down the cube? Is it larger than 3? It shouldn't be. So you've got 3. Why do you have... Oh shoot, I messed up again. So for each direction, you're not supposed to calculate the directions, but only if memory 2 is a data cube. So if around you see a data cube in memory 2, that's when you're supposed to increment your counter. Oh, stupid me, idiot. Alright, now they're moving the cubes. This seems much better. Is this gonna work? I don't think it will. Well, it will, but it's gonna take a long time. They are basically failing to pick up this cube. No, that's fine. This cube. We need them to pick up this cube. Yeah, it's gone. Is there anything else that has 4 neighbors? Alright, we're done. Shit. It took about 400 seconds. That's way too long, and we've used 16 commands. So basically, the game is trying to tell us that the code I've written is fucking stupid. I hate when someone tells me my code is shit, mainly because they are usually right. So now what am I supposed to do? I think we really need a grid search, but I can't be bothered to write one. I just need to see the layout of the people. Is there something about it? Can they perhaps go in a diagonal? Because here they are 2 steps apart, so they could take these diagonals. These people here could take these diagonals, but they might miss one. Yeah, this one. They would miss this one. What if I tell them to go to the nearest wall? Maybe I would be able to see a pattern there. And also I want to try the checkerboard pattern to see if there's something there. Step to nearest wall. They've all closed their eyes because they smashed into the walls. Just do it slowly so I can examine you. Stop talking. Alright, so for example, this first column, there's no one there. This first row, no one there. Third row, no one. This row, also no one. Meaning we would miss a few cubes here, but we wouldn't miss the others, so it wouldn't probably matter. Alright, and checkerboard. If we were to take every second cube out, that would work beautifully. But we would need them to keep going in that same line for them to take the data cubes out. How the shit am I supposed to do this? I mean, I could leave it like this to be random and just optimize it, that even though they're not standing on a data cube, they're gonna count and, you know, remember the spot that they are in and they're gonna place the data cube there later. So once they counted all the, data cubes around them, if they are holding a data cube, they drop it. Otherwise, they remember that spot. So in memory 3, remember where you're standing. I hope it works and that they're not gonna set 0 in memory 3 because there's no data cube there. And once they pick up the data cube, before they jump back, they might want to say if memory 3 is initialized is not nothing, let's say, then you step to memory 3 and you drop your data cube there. Would this perhaps work? So let's take this person. I hope they're gonna calculate. No, they're not calculating shit. So you're not holding an item. Your item is not a data cube, so don't drop it. And in memory 3, you said nothing. Okay, so I guess they can't remember the spot that they are standing on. That's kinda shit. This was a waste of time, so let's reset that. We could say, every time you pick up a cube, you might not want to place it down at around the same area. So how about you go to the nearest wall? So here, again memory 3, let's say nearest wall, and once you pick up a data cube, step to nearest wall. So memory 3. Let's do this a little faster. So they're basically taking the cubes from the middle and going to those walls. The problem is that once they go there, they're stuck there for some time until they can randomly get out from that wall. But I think, yeah, that was really faster. Like twice as fast, we only need to shave off 6 seconds. And I honestly don't know how we can do that. I think that's gonna be like not a major optimization, just a minor one, like this if statement or, slapping those two if statements together. That would actually be a huge help. I'm not good with optimizing if statements like this. You basically want to, write it down with the brackets or the other if statements in brackets and then multiply the booleans together. That really sucks. That's why you use a good IDE, a good code editor, which does that for you in case you need it. So if you are not holding an item and something, or are holding an item and something else, does it matter whether you're holding an item or not? I don't know. It seems like those two if statements are opposites. Not holding an item, not standing on a data cube, holding item, standing on a data cube. But those are just, 2 cases out of how many? 8? There are basically 2 things we wonder about, and each of them can be true or false. So there's 8 combinations, isn't there? True, false, 4. Is it 4? I don't know anymore. Yeah, I think it's only 4. I'm an idiot. What I could do is put this if statement, if memory 1 is larger than 3, memory 1 is the amount of cubes around you, inside this other if statement. So you're calculating, looking at the cubes around. If there is a cube, you increment the counter, and only then it's worth checking whether the counter is over 3. This could make it a little faster. Let's see. It's still gonna take a long time, but my hope is that this time we might finally get there. It's really slow. Come on, find the last cube, you idiots. Finally. Yes, nice. Conquered the time. 164 needed 175, so I'm happy with this. That's nice. The only issue is that we need to use 10 commands and we've used 16. Now, time complexity is out the window. So I suppose we shouldn't have any checks for pickups and drops and optimizations like this. Nearest wall, don't care about that. Just keep stepping, and we might not even care about this, but I'm gonna leave it there for now. Memory 1 is 0, then for each direction, if there is a cube, you increment. And then, if it's larger than 3, we don't care about that. Let me put this there. Oh, sorry, we did care about that. Shit. If memory 1 is larger than 3, you should pick up the data cube. I don't care if you're holding one or not. and drop it and do it like that. No. No. If it's larger than 3, you shouldn't drop. So else drop. If it's larger than 3, you pick up. Otherwise, you drop. Don't care about this, don't care about that. Because that was just optimization. So basically, count all the items. If there are more than 3, you want to liberate the data cube. Otherwise, you want to drop your data cube. You might not be holding one, you might not want to pick up one, but repeat that. This is 14 commands, this should already work. I just fear that them calculating all the things around them is going to be way too slow. So I honestly don't think this is going to work because of the time issue. I said we didn't care about time, but we can't be over 500 seconds. But so far it seems to be working. It's just truly random, and I don't know how long this is taking because of the times 12 speed. But I can feel my facial hair growing. Come on, you're almost there, just find the cube. Just the last one, there. Oh shit, the target was 10. I'm a fucking idiot. Well, anyway, it was some of those were way over 500 seconds. Why did I think... So it can be over 500, alright. So we might not even care about these two if statements, right? Because those are the 4 commands that we're over. Remove that. I'm going for a walk. See you in 20 minutes? Alright. Alright, it's done. 10 commands, yes. And it was at 0 at first. 800, alright, so maybe they changed it. But I have no idea what the maximum is. Oh shit. This one is over. But I don't know how long that was. I mean, we've got 925 here. And this is like a third, maybe even a half more. So like 1300 could be. So they kept the layout for me to try again. But basically, their steps are random. So I think I can just run it all over again. And we'll see. Okay, program taking too long. So what I'm gonna do is try to cheat the game a little. Run my faster program here. So let's do that, be fast. Then I'm hoping this will reset the probably static random counters that the game is using. And then I'm gonna run the slow program again. It only failed once out of those 25 tests. So I think we should be fine. And as you see, this was my fast program, which originally had 164 seconds. And since their walking is random, they're at 184 now. So this is gonna work now. Or this. I went to grab a bite to eat because it was taking way too long. Anyway, that's it. 10 commands. We needed 10. And the time is not even that bad. Did I mess up? Was there like a very simple and easy solution to this? Please do let me know.